So good day, everyone. I hope all of you are having a nice day. May I please have your attention for some minutes for we are going to discuss the use of ECDIS for passage planning. So we are the group 10 of MTEC FS Friday Saturday schedule 0900 hours and to 10:30 hours. So, along with me, my name is Bendijo Leo Evan. Along with me is Mr. BULAWAN, John Ronel, MONTEHERMOSO, Archie, OGOC, Giancarlo. So, ECDIS means Electronic Chart Display and Information System. So, actually, in passage planning, there are 4 key elements. First one is appraisal. Appraisal means you have to conduct or appraise all necessary informations with regards to your passage. And then next one is the planning. You plan for the passage or your intended voyage. And the third one is the monitoring. I mean the execution. After you appraise the informations, after you plan for intended voyage, and then that's the way you have to execute your intended voyage for your passage planning. And then the last one is the monitoring. It means monitor your track, monitor your passage. So ECDIS checks prior using ECDIS for appraisal and passage planning. So the very first step for passage planning is appraisal. So following checks should be carried out by the navigating officer while carrying out passage planning on ECDIS. Not all sea areas are covered by ENC chart or electronic navigational charts. Electronic chart voyage coverage for the voyage must be adequate, and all relevant charts must be fully corrected. For areas covered by ENC, it is mandatory that they would be used instead of RNC and are to be used instead of updated paper charts. Areas for those areas shall be made available on board. Then, after that, check local requirements of coastal states that may require carriage of additional publications or local charts. If there is another or any additional publications, local charts, you have to check. Check electronic charts have been updated to the most recent version and chart permit licenses have been bought. So you have to be all charts must be updated for your intended voyage. And then the vessel's controlling operation parameters: maximum draft, air draft, turning draft, minimum under clearance, required look ahead distance, and etc. should be entered. The GPS position system should be set to WGS 84 datum. So the alarm functions of the ECDIS should be fully operational. They will alert the operator and any danger exposed at good time during the voyage. Carry out the route check to ensure that the vessel will not encounter navigational hazards on the planned route. A visual check of all ENCs being used for the voyage at the best scale must be carried out. So, to appraise, everything must be updated. Everything that is necessary for the intended voyage must be checked. So, this one looks like in the ECDIS. So, use of ECDIS for route planning. ECDIS provides many benefits for route planning, a few of which are quick and easy to select safe routes and prepare new ones. Routes can be easily modified with the use of the planning graphic tool. Measurements and calculations are much easier. So in the picture shown that there are made routes for intended voyage. As you can see, there are lines along which the vessel is on track. So that will be on my part. I hope you're having a nice day.
However, planning a safe route requires experience, time, and adequate familiarity with the general principles of ECDIS. A navigator should be aware of the following. Check route function. The navigating officer should make use of the deck route function after passage planning to ensure that the vessel will not encounter navigational hazards on the planned route. These hazards would be mainly pertaining to grounding dangers, crossing TSS line, or boundary and user-defined alarms. So, markings on the chart. The electronic chart should be marked with first, prominent navigation and radar marks. Second, parallel index line, not from floating objects unless they have been first checked for position. Third, no-go areas. Fourth, landfall targets and lights. Fifth, clearing lines and bearings, safe distance off. Seventh, transit heading marks and leading lines. 8. Significant tides or current. 9. Safe speed and necessary speed alteration. 10. Call master point or changes in machinery status and notice for main engine or anchor clearance. 11. Minimum underkill clearance. 12. Cruising and highly density traffic areas. 12. Contingency plans on abort position. 14. VTS and reporting point. And the last, any other user-defined notification as considered necessary. So, execution and monitoring. For changing over the watch while underway. Checklist to be complied with for carrying out checks on ECDIS. Check that the display has been set up properly prior to sealing, and otherwise important information may not be displayed. There are generally 3 default settings of the layers of an ENC. Based, standard, and other, the ENC should normally be in a full access mode. In case the text information clutters the other chart information, the text layer may be disabled. So, this is an example of ship route plan. So, day and night setting, the display should be set to meet the appropriate condition of the bridge. So, there are 3 main viewing modes available: daytime, dusk, and nighttime. Caution: when using night or dusk setting, background colors get altered and shows. Other dangers may not be readily apparent. So, until good orientation is achieved, it is advisable to switch to day setting occasionally. So, always use ANC on the best scale possible to avoid crucial information being auto-filtered and subsequently not being displayed. When executing a route, progress against the original plan must be constantly monitored. So, navigating officer must not become over-reliant on ECDIS. Frequent check should be made of the ECDIS position fixing system, normally GPS. So, by the use of other means to cross-check and determine vessel position, such checks should include.
So, parallel indexings and use of clearing bearings, visual crossing bearings, use of radar to check the accuracy of the charted position, comparisons of signal to noise ratio of the GPS system, and use HDOP value. So, this is the illustration. So, the critical alarms and alarm setting guidance. So, during passage, if any of the below alarm is received by OOW, should immediately inform master. So, crossing safety contours are diff. So, there are generally 3 contour settings available to the user for highlighting available depth. So, the contours are differentiated by colors, and if a guide zone touches the safety contour, it will give an alarm. The contour will be selected only for that value for which a contour exists on the ANC. If any other value is selected, it will then select the next available contour.
So, area with special conditions or the geographic area. So, an alarm or indication set by the user will be given if within a specified time or distance on-ship would cross the boundary of a geographic area for which a special condition exists, such as traffic separation zone, caution area, anchorage area, particularly sensitive area, sea area, or military practice area. So, the size of anti-grounding tool will depend upon manufacturer or ECDIS system in use. Within the option provided by the manufacturer, master should decide the optimum setting of size for particular passage or leg of voyage, vessel size, maneuverability and speed of the vessel, proximity of navigational hazard, position plotting, frequency, and etc. So, this is the illustration. So, monitor UKC all the time. VSL will cross shallow contour, reduce speed by 3 knots. So, that's all. Thank you.
Contour. A. Calculate safety dip and enter into ECDIS. B. Select viewing groups for sounding seabed features and contours to be displayed. C. While running route, check if passage is found to be navigating safely through safety contour. It will be required to draw an artificial safety contour. D. Construct a manual update line to create an artificial safety contour equivalent to the safety dip using the highlight safety dip as an indication of the contour. A. Allow a safety margin where dip values displayed are less than the safety dip value. If using existing contours to establish the likely shape of the manual contours. So, kaning contour is aligned separate a minimum dip area. For example, 10 meters contour. So, maunay line separate sa water below and above 10 meters. So, kanang contour na siya value for example 5, 10, 15, 30, 40 and so on. So in ECDIS makita nimo siya or klase siya og contour. So na siya shallow contour, then safety contour and deep water contour. So ang pinaka-importante gyud ang safety contour which is parameter na siya parameter which is maka-display siya og unsafe water areas. G. Set the manual update line as a alarm feature. Refer to the ECDIS and training course notes for guidance. H. Run the route check facility to confirm the feature will alarm. I. Ensure the plan is clear when the safety contour should be set to the artificial value and reset once the area is clear. Then J. Save as a part of voyage plan in ECDIS and note the feature in the voyage plan for review and approval by the master. K. The areas where vessel track is to navigate through safety contour should be mentioned in passage plan and discussed in passage plan meeting. I. If there is tidal window required to cross such area, same to be noted on ENC or electronic nautical chart. So, ang kaning safety dip setting or safety dip, ang purpose ani is to portray spot sounding. So, for example, in ECDIS, na siya color gray, it means for deeper deep. Then, ang black, it means shallow deep. So, markings on the ENC or electronic nautical charts. Then, ENC allows navigating officer to insert additional information using navigator's notes or mariner information overlays or MIO. Such facility allows the placing of the text notes in symbols in presentation library or simple lines areas with or without color fill. The presence of a text node will be identified in the charts area at defined geographical point by explanation point or I. Then kaning ENC or electronic nautical charts makaprovide siya og additional information. So including the real time information. So makita siya sa screen sa ECDIS. So this picture example of kanang makita nimo sa ECDIS. So makita nimo dire ang shift deep. So napo siya deep number. Then as a navigator, we need to have more understanding and learning about ECDIS. So that's why there is ECDIS passage plan. So we need to plan to proper execute para dili mahitabo ang accidents like kanang sa barko, like grounding. So that's all, guys. Thank you for watching. I hope you learn something. So that's all. Thank you.